Alright guys, welcome to another video. Today I'm really excited to do this paper. I got this paper from Stanford. It's a web applications paper. Let's solve this one together. Let's quickly go over the questions. Let's see what you guys are getting yourself into. Like once you're going to Stanford or some other institute, you're gonna have to face these questions. You're gonna have to go through this curriculum, and at the end of the day you will be facing these exams sooner or later. So let's quickly take a look at this and see how these questions can be done, and really what is the level of the questions and everything. Okay, basically if you're going for a master's or bachelor's, this is one of the courses you will come across. And again, I'm not doing this question these questions extemporaneously. I have actually seen the questions first. I've actually analyzed them. I have some questions I just didn't get. I had to see the answers on the internet. So all of that has been done beforehand. It's not my first go, so some of these questions are really hard, but sometimes a lot of you guys might think that it is easy. It depends from person to person, really. Okay, so let's just get on with it. I'm gonna bring on the paper and let's start. Okay, great, let's begin. So this is the CS 142 final examination for the winter quarter 2016. Right now the 2018 quarter is running, but like I said, I even have the 2017 paper, but I'm gonna begin with the 2016 one. Doesn't change, a lot doesn't change over here, but I just started it. I just started with this. Okay, so this is a web applications. The subject name is web applications, and if you want to find out more about the subject, or check out more papers on the subject, you can go on to cs142.stanford.edu and you will find the website where I got these papers from. Okay, let's begin. By the way, you have 3 hours to solve these questions. There are about a total of 18 questions, and you have a total of 180 points which you can gain. You don't have to basically you have to take all of these questions. You don't have to write paragraphs and use paragraphs. Your answers can be succinct, but they should be they should really be answering the question. One more thing here, that you have to follow the honor code, and basically during the examination you can use 2 double-sided pages of notes. Now usually what happens is you have 2 double-sided pages of notes. You can write things depending on the subject. Sometimes it's just formulas, or sometimes it's just values of constants. So really, depending on your subject, you can choose to write something that you might want to write over here, some piece of code, something you can write over here, and you can refer to these pages during your examination. Okay, apart from that, nothing else is allowed, and basically you have to fill this out. Again, question number and the number of points for that question number are referred over, mentioned over here, and you can check these out. I'm gonna just put this away and let's begin with it. Okay, so this is the first question that you'll see on the paper. And by the way, both of these points you have to do to get the 12 points. One is 6 points and the other is 6 points. Okay, so the first question is basically that you have to explain why cloud computing platforms work well for web application startup companies, and because they're starting small, basically, and they're hoping to make it in a hurry. So you have to explain their situation and tell them why cloud computing is a good measure for them. So the thing is that the answer to this question, you can just write it down over here. I'm not going to do that. It's a theoretical question, but the thing is that cloud computing provides quick infrastructure, and you don't really have to own the infrastructure. You don't have to invest in it. So because of that, it is a great benefit for these companies which are really startups. They don't have a lot of capital to invest in huge infrastructure which costs a lot, and they can just deploy their web application on platforms such as GCP, that's Google Cloud Platform, or AWS, or something like that, Microsoft Azure. There's just a lot of platforms they can refer to. So that's your problem number 1, question A. Let's go on to the question number B, and it asks you to explain why it is easier for a web application with many geographically distributed users to deliver read-only content such as images to its users' browsers than non-read-only content. So basically the question is asking why it is so that non-readable content is a little more hard to deliver than read-only content. You have to explain that. Okay, and the answer to this question is for read-only content, which is your files of, like, let's suppose JavaScript files or something, you can use a content distribution network, that's a CDN links. And basically you can use CDN links depending on the geographical location of the person who is using your application. And because of that, it's going to be like, you know, your web application can be a lot faster if you're using that. And non-read-only content is kind of served from just one location, that is your web server. So that would really, you know, depending on your location and relative location of the users, it would be different. Okay, that's your problem number one. Let's put this away and work on the second one. The second problem asks you to give an example of a denial of service attack that a user could do on your project number 8 photo sharing app. So by the way, this photo sharing app, I checked this out. This is just, you know, kind of like Instagram. You can think of it as Instagram, okay? And you have to describe how you could change the app to defeat this attack. Now, a denial of service attack is where basically a user is kind of using his own computer, and he's basically opening up multiple terminals and sending in a lot of requests from all of those terminals, supposedly, you know, thousands or hundreds of thousands of requests at the same time. So what will happen is that your web application server, even while it's working asynchronously, it will not be able to take the load at times, depending on the you know, server specifications, and people will not be able to visit. Even legitimate users will be blocked out of the website. You know, sometimes you just go to a website, it just doesn't load. That's you know, kind of what is going to happen. So that's the denial of service attack. And what can you do to change the app to defeat the attack? Well, you can, first of all, you can do something like this. You can put on quotas, supposedly that, you know, a user cannot upload more than 5 photos in 1 hour or something like that. You can do, or maybe you know, more than 10 MB of data per hour. And that's gonna kind of protect your application from these DDoS attacks. Okay. Otherwise, you can also go for premium services like Cloudflare DDoS protection, which should also cover DOS, denial of service attacks. So that's something else you can do. Next question is for 5 points, and that asks you to explain why you should make a habit of looking at the URL bar of your browser when using a web application from a trusted site such as a bank. Describe what you're trying to detect. Now, the answer to this question is, if you've ever heard about phishing attacks, that's the answer to this question. Sometimes, you know, these websites, you know, bank websites, they need to be really, you know, you need to be really sure that you are transacting with the bank website, actual bank website, and not some malicious website that's just put there, you know, which has been copied from the actual website, and they're just trying to take away your money. So when you do that, you should really look at the URL, and you should check for the SSL or TLS certificate. Basically, if you have HTTPS in the link, you know, the website is secure, and it's using you know, secure means, encrypted means to kind of transact with you, and that's what you're trying to detect. Okay. You can also try to detect the phishing by checking the link if it is exactly the same as the bank has specified. Okay, so let's move on to the next question over here. And this is the third problem. It says, when exploring the MongoDB object of a photo sharing app after a security penetration tester had been running on the system, you noticed several users were created with weird names like this. Okay, given an educated guess what the security tester was doing by creating a user with weird name like this. Describe the security loophole and what the penetration tester was hoping to see if the loophole was present. Well, these are Jinja expressions, and my guess is that, you know, when using MongoDB, you know, he was trying to see if basically, you know, some framework has been used which can process these. You know, these are kind of JavaScript processed. So instead of this, you know, what actually is stored in the database can be 1337, and if this is stored in the database instead of this weird looking thing, well, that means that he's found a way to run the JavaScripts on your website, and because of that he can just, you know, run more malicious scripts over there. All right, that's the third question. Let's move on to the next one. Question 4, what is the difference between HTTPS and HTTP? The main difference is basically that you have like encrypted mechanism over here. So like encryption is done when you're transacting with an HTTPS web server. In case of HTTP, no encryption is done, and basically the data is prone to sniffing or spoofing. Okay. B part. This says that describe how a web server can tell if an attacker in the browser has tampered with the session information in cookies it sends to the browser? Well, this is easy because, you know, the web browsers kind of use MAC, which is a message authentication code, and on the basis of that, you know, you can think of it as a checksum, and they're trying to see if basically, you know, everything is just right when you know, from position A to position B. Whenever you send something, both of the sides MAC will be checked and basically confirm that they are equal. So if they are equal, then everything's right, otherwise it isn't. So that's how it is. Let's look at the problem 5 now. It says, explain why a web application coding standard script might demand the script tag for including JavaScript libraries looking like this instead of this. Okay, so basically the only change in these things is the domain name is included over here. So why this one might be demanded and this one might not be? Well, this is because if you're using this one, you're basically using the resources from the, you know, like you're not mentioning HTTP or HTTPS. That's the main, you know, point over here. Like here, HTTP is mentioned, and if you're running your website on an HTTPS based server, well, it's in your JavaScript console, it's going to be showing the error that you are trying to load a script from an unsecure source, and basically that script won't run. And that's really the main reason why you should go with this and not with this. Okay. The next one, we should look at this one. Describe the mechanism used by the web application to prevent its session cookies from being used by a web application from a different company. Well, they basically try to use this same origin policy. There's something called like that, and you know, it's like the origin is kind of checked everywhere. Like everywhere this page is requested in the GET request or something. So you can, because of that, you know, you another company cannot be trying to be, you know, in or basically represent another company. That's really it. Okay, let's look at the next one. Problem number 6. Describe two different ways information such as parameters can be sent from the browser to a web server using an HTTP post request. Well, you can either send it using the form tag, or you can send it using an API call in the JavaScript. API call, you can make that, and you can do that. So these are the two methods. Describe how a browser decides how long it can cache a web page it fetched with a HTTP GET request. Well, in the HTTP GET request, when the browser kind of sends the request to the web server, well, what it's going to do, it's going to send the response, and in the response there's going to be something called as the header, and in the header there's something called as the, you know, cache control field, which will specify how long this data can be, you know, saved. Okay. In the mean stack application state, what is the order that the model view controller components typically arrive at the browser? Well, the order is really that first of all the controller comes, which then calls the basically uses the model to make changes to the view. So basically, you know, it's like that. You can also say that, you know, the control and the view come in simultaneously, and you know, using those you can, you know, work with the model after that. The model comes after that. So these are the two acceptable answers. Both of them are, you know, acceptable and will give you the full points. Let's look at this one. REST APIs are frequently described using CRUD. What does CRUD mean? Well, CRUD means, you know, create, what is this? I think create, read, update, and delete. REST APIs are defined by these operations: CRUD, CRUD. Okay, and create is just basically post request normally, and this is a GET request. This is put or patch request depending on your situation. Patch is always preferred, and this is a delete request. Okay, great. Next is explain how the Node.js buffer class avoids having to allocate. Okay, this is a Node.js question. I'm just gonna like skip these because, you know, some of you might not be familiar with these. But again, the thing is that, you know, it's just about how the buffer is used, and basically it helps with the use of pointers to kind of, you know, fasten the process, something like that. So let's not get into this. Okay, explain why a JavaScript functions takes multiple seconds to compute. Example, cryptographic library functions are problematic in a Node.js server. Describe the problem. Well, this is kind of generic. Sometimes, you know, one script A requires that script B has already run before it, and it basically waits for the callback from script B. When the callback is given, only then the script is loaded. So this is something that can be problematic on the server, and that's why they can take multiple seconds to compute. Okay. This is a purely, you have to find the fault in this question really, and this is kind of an AngularJS question. Let's not get into this again. Okay. Give an example of functionality that is implemented using Express middleware. Briefly describe how this middleware works. Well, the Express middleware is kind of used for dealing with session states. So even on the server and on the a web application which is using the cookies, basically both of these sides have to be synchronized, and the state has to be since HTTP is not stateful, so the middlewares have to be used for that. Express middleware is explicitly used for that. So this is the answer to this question. Okay, this is the definition that the Mongoose system. Mongoose is just kind of you can think of it as MongoDB. The definition that the Mongoose system we used for our PhotoShare app looked much like an ORM, object relationship mapping, that was used in older framework like Rails. Explain why it would be incorrect to call these definitions ORM. Well, we haven't really seen this app, but again, like I told you, this is like Instagram. So the thing is that in a relational model, the mapping is done from functions to kind of they make kind of the database structure is kind of changed because of the ORM, and my guess is that MongoDB does not use that. Okay, moving on to the next question. What we have here is that explain how indexes make database queries go faster. Well, indexes do make it faster because you don't have to look up in the database for the every single row. You don't have to check if the query you're looking for is present in this or this. Oh, I finally found it. You don't have to check these. No, you can just use indexes, and that's gonna make it a lot faster. Describe the disadvantages of having indexes on every property of a commonly updated object. Well, indexes do take up space, and sometimes they can take a lot of space. So that can be a really real reason not to use it in certain kind of applications. So these are the disadvantages. Next, we have explain why you frequently end up validating input in a web app twice. First in the web browser, and then again on the web server. Well, the web browser, basically that's you can just run the script on the same page. If the user does not enter the phone number in the phone field, he kind of ends up entering an email address. Well, you can just make this thing go red and disable the submit button. He cannot really submit it. All right, so really it's a lot faster. He doesn't have to send the responses and fill up the whole huge form again. So that's that logic. On the web server, really it's for the protection of the server. Make sure that nothing wrong has been entered, and basically our database is secure. So this can also help in preventing attacks of different kinds. Great. Let's look at the next one, and this one says that for each of the following web application security attacks, state if the focus of defeating the web attack would be more on the front end or back end. So front end is again your browser side, and back end is your web server and storage system. Where should you target to prevent these attacks? Cross-site request forgery is kind of primarily targeting to hit your backend and use some kind of JavaScript over there, and basically not use some JavaScript. That's scripting attack. In the forgery attack, the get parameters are kind of changed, and basically the request like you can say cookie stealing or something like that is happening over here, and this is only checked at the backend because the request parameters can only be checked at the backend. So I'm going to say this is the backend. Okay, scripting attack, like I said, it's performed on the front end because a script is trying to be run, so this has to be checked on your front end. SQL injection is trying to harm your database, and basically if something is trying to harm your database, where can you take action? It's in the backend. You need to check everything is in place. Okay, phishing attack again happens on the front end, and basically the main focus should be on the front end. Denial of service attack again happens on the back end, and like I said, quota management or something, you can do this on the back end. Okay, let's look at the next one. And this one basically tells you that you have web servers communicating using HTTP protocol. Even though all HTTP communication follows a request response pattern, information can be viewed as either being passed from the web browser to the web server or passed from the web server to browser. Okay, so basically what you have to do is over here you have to specify if this is the browser to the server or from the server to the browser. Can be even both, and you have to specify that as well. Also HTTP methods have to be specified. That's get, post, put, patch, delete, all these things. Okay, Angular HTML templates are sent from the from your server to your browser. Okay, CSS style sheets are sent from the server to the browser again. JavaScript libraries again server to the browser. Model data that is sent from, well, it can happen in both directions. The model data is basically sent from server to browser or from browser to server. Okay, and the last thing is that Angular controllers, well, these are sent from the servers to the browser, of course. Okay, if you know anything about Angular, you will understand this. If you don't, that's completely fine. Don't worry about this. Okay, again, the requests have to be specified. Definitely, whenever it is from the web server to browser, all of these are get requests, get request, get request, get request, get request. This one, however, is a post request, browser sends to server. Okay, model data is being sent. It can also be sent using the get parameters, but again, most of the times it's a form field which is using a post request. Okay, last two questions. Let's put this away. And this one says, okay, this is again a completely Node.js kind of a thing. If you are not familiar with it, I don't want to go over this. It's relatively advanced. Let's leave this. Okay, here we have been given kind of like a diagram, and we need to kind of give it labels, and the options are given right over here. So what can all of these things be? A, B, C, D, E. So again, I think this video is already long enough, but this is the DNS server, of course, because this is going to the photoapp.com from here. DNS lookup happens over here. So this is the DNS server, and well, the browser is going to send a get request over here. So it's going to be a HTTP get request, and this is the web browser, of course, web server, you can say, something like that. Okay, again, the request comes back in, and well, really, we don't have to do this, but I don't know, let's just get over with this. You can call this the HTTP get response. This is the request, this is the response, and basically that's it. Oh, I left the, okay, when the request is sent for the DNS lookup, this is the DNS response. Okay, so that's about it. I'm gonna leave this question. This is again not really a lot, but like in what order this happens. All right, let's just do it. Well, the DNS lookup first, the DNS response after that, and after that comes the HTTP get request, and finally your HTTP response to the browser. Okay, so this was a quick paper, and I think it was pretty easy. If you like, this is one of the courses that you might be taking up. Depending on your specialization, you can do a dual depth or a single depth when you're going for your master's. So this is a very great course, I think, and thank you for being with me. Thank you for watching this video, and I'll see you in the next one.